Wonderful. Thank you, Ashley. And thank you, Clayton. I think we both went through a little bit of a temperature change, at least in northern Illinois, the last couple of days. So forgive my throat, it's a little scratchy. So I'll be annoying you with an occasional cough. Anyway, today's presentation will be two products. And I won't bore you with a lot of PowerPoints, but just to start things off here, yes, my name's Tad. I'm in Northern Illinois, and we're going to cover a couple topics: the Inventor Nesting Utility for sheet metal parts, and I'll explain that a little bit more, and also manufacturing, to where we'll get into the HSM and how the workflow from a nested sheet can then be used to manufacture that sheet with HSM. And the beauty of this presentation really is that we will never leave Inventor. It's a nice, consistent workflow, all within the Inventor environment. Okay, I already covered that. We'll get into the nesting utility, the user interface, the workflow. I'll then go into HSM, all again within the Inventor environment, and then we'll post some G-code out to show you that also. Now, this isn't really a training session. It's more to turn you on, I guess, to products that you very well may already own. And a lot of people weren't necessarily familiar with that. The Inventor Nesting Utility, Hagerman and Company, just our little bell and whistle here. We do have offices throughout North America. One of the top resellers for Autodesk in the country. I think we might actually be the #1 private reseller in the country. But the reason I like this slide is because CAM, or manufacturing, sheet metal and machining or turning or whatever it might be, is not new to Hagerman and Company. We were in that camp actually long before Autodesk was, and so we have well over 30 years of CAM experience, dating all the way back to SDRC Ideas at the time, which was a direct competitor of Pro Engineer. You know, it ran on those big, bulky Unix workstations. Then we moved into the PC role with SmartCam. That pretty much dissolved on us. So we had an opportunity to go shopping ourselves, so we chose EdgeCam. And EdgeCam, we spent a lot of years with them and had a lot of success with them. And then on the HSM, when Autodesk acquired that, and I emphasize acquire, we got in the camp with them with the HSM product. And I do want to point out that while HSM may seem new to you or to Autodesk, the product is not. It's the product has been around for quite some time. It's a very mature product. It works inside of Inventor, and it does also work inside of SolidWorks. And you may have heard quite a bit about Fusion and Fusion 360, so forth, which is the cloud-based Autodesk solution. The Fusion product does include CAM or HSM, so there's quite a few opportunities there for you to use this technology. And I also like to mention that HSM does stand for high-speed machining. We use it on lathes, plasma, water jets, etc. So at Hagerman and Company, it's not just me or me and Clayton. We have multiple technical people on staff that can help you get basically from concept to manufacturing and your product out the back door as quickly as possible. The nesting utility, a couple bullets on that. It is embedded within the Inventor environment. We emphasize the word sheet metal a few times because from a solid model perspective, it does require a sheet metal part or an assembly that contains sheet metal parts, but it's not limited to that. It is available to you right now if you're on subscription or maintenance or whatever they call it today with the product design and manufacturing collection. You have these tools now. The nesting studies that we'll see and that I'll do for you today can be created, updated to reflect any changes in the design, and there again is the beauty of working from within the Inventor environment. Everybody is married together and everybody works together. And you can run multiple nesting studies also, changing gap and kerf and so forth to optimize the efficiency and actually look at those studies and analyze those studies yourself to take advantage of material. It does currently work on Inventor sheet metal parts with a flat pattern. I mentioned that, but in addition, there is a DWG and DXF extensions that are also supported, and I'll show that to you also today. If you log into your Autodesk account, or if your account manager logs into your Autodesk account, you'll see the nesting utility, and you'll also see HSM. So one thing that does hit our support desk occasionally is, where is my nesting utility? And that's the reason for this bullet. The nesting utility is not a part of the typical Inventor installation. You will need to access your Autodesk account page and download the nesting utility and install the nesting utility. It is an add-on or an add-in with the menu system to the Inventor product. Currently, it does require Inventor version 2019. Now, stepping into the manufacturing and the HSM CAM solution, basically very similar bullets here. It is available to you now from your Autodesk account page. It is not a part of the Inventor install. Like we saw with the nesting utility, you will need to download that, and you will need to then install that separately. HSM requires Inventor, as does the nesting utility. It runs inside of the Inventor application. And support for HSM right now, it will run on Inventor 2016, 2017, 18, and 19. Now, Inventor HSM, for the most part, we are constantly involved with clients who use the HSM solution for their milling machines and their turning machines, lathes. But it does also support now plasma, laser, and water jet. And that's typically where that's where our focus will be today, is again more on nesting and then taking those nests to manufacturing and applying them on a plasma, laser, or water jet machine. Just a quick snapshot of what you might see when you log into your Autodesk account to access these solutions. The Inventor HSM utility, you can see, is listed separately and is a separate download and a separate install. And it, in addition, the nesting utility at the bottom is the exact same thing. So don't be looking for it just after an install. And we can help you with this if you need it. Also, one of our goals is to make sure that you can install and launch the products that you own. So enough of the PowerPoints for the moment. Let's jump in. And hopefully there's not too much of a delay that's one of the reasons I speak a little slow, is we're at now inside of Inventor Professional, and I have on the screen a assembly, and the assembly contains multiple components, obviously, but what you'll see is on the left in the browser that some of those components are sheet metal components, and that is one of the big requirements when working with the nesting utility, that it does require sheet metal components. So just to change it up just a little bit, over on the screen now is just an individual piece part. We get a lot of interest from the woodworking community for nesting also, and I wanted to point out that yes, we can work with individual flat patterns. The only thing that I did, because of the requirement of the nesting utility, is I built this using a sheet metal template, and then I generated a flat pattern from within the Inventor environment so that the flat pattern would be there. Now obviously there's no bends on this, but I'm still able to do that on just a very simple sketch and extrusion. So it does work from within the woodworking industry. And then in addition to that, stepping over here just for a moment into AutoCAD, prepared ahead of time, I have created a L bracket, which is a DWG file in AutoCAD, 2D flat, and a triangle, which is a second AutoCAD DWG. And then for kicks, just to take you kind of all the way down to the DXF, I then exported those out as DXF files to prepare for today's presentation. I hope that we don't have to go into the AutoCAD side of it too much today, because we don't really have a lot of time for that, but it's basically just an AutoCAD DWG file that has been exported out as a DXF. But again, it does work with both the Inventor Nesting Utility does work with both DXF files and DWG files. I'm going to put that away. So to start, I thought I would kind of go from the ground up, where we'll start with the DXFs, then maybe go to the wood single piece part, and then finish up with something a little bit more elaborate with the assembly environment that contains multiple parts. The first thing that you'll notice is that nesting is nowhere listed here. Up at my ribbon, we don't see nesting, and you can hunt and pick all you want, and you won't find it. And this was one of the initial calls and learning that you'll have to go through, is that if you jump over to the home screen or back to the home screen where nothing is really open in this screen, the nesting utility suddenly appears. So if you're within an assembly or within a piece part, you're not going to see the nesting utility. You need to go home, or you need to close out those files. The nesting utility, it is again an add-in. See, there's not a whole lot here to it, although once we get started, the ribbon will expand. There's an options area here where you can go in and control your display, auto saves, configuration file that we won't get into too much today, as far as controlling your nesting and materials. And I will show you the materials also. Excuse me. Now, the nesting, when you launch the software using the nesting button, completely changes your environment, obviously, and it brings up a browser that shows you the calculated nest and the end result of that nest. Now, there's nothing here, so obviously the first thing that we'll need to do is tell the software what is it that we're going to nest. And we typically work from left to right, so I'll click on the sources button. The sources are the components that we're going to nest, and I'll go ahead and add And here on the filter, you'll see again DWG, DXF, IAM, IPTs are supported. So I can use my keyboard and select that triangle DXF, and then also select the L bracket DXF, and it will bring those two files in as my source. It gives them a nice check, extracts the processes, tells you again what it is that we're working with, and we have 2 occurrences. So that's not that difficult. We'll go ahead and OK that. And it then brings in those DXF files together, and it can be 1, 2, or 22, or 200. It will bring those in and display them on the screen for you. From here now, we need to, so we've established what components it is that we're interested in nesting. So we're going to now go to the nesting properties. Sorry. We're going to go ahead and create the nest. And in doing that, we're defining the nesting study. And it's just using a study 1, and the next one would be study 2, and so forth. And from inside this environment, we can control the thickness based on the package or the inventory that you have out on the shelf for the sheet that we're working with, and how many of those sheets you might have available to you. We can control the 2 shapes that are nested. The job quantity here is 1. I'm going to go ahead and I'm going to purposely make some mistakes just so that we can go back and you can see the edit. So if we OK this, the software will translate and develop for us a nesting study. And here we have that study, and you can see that the 2 components were orientated based on my control or your control and put together into a nest. Now, the nesting study is something that you can easily go back and edit and so forth. So if we go back to that study and edit it, we're back to a form that's similar, but this is where, again, you define the source, the sheet that it's running onto, and the quantities, the orientation, whether or not you'll allow it to mirror or not, your choice. Are you okay with rotating things, and would you like to control those rotations? And if you are okay with rotating, do you want to limit the rotation angle in any way? You can do that here also. Now, the quantity was set up with just 1 study, so I'm sorry, 1 job. So I can come in here now and change this and say that L bracket, I really need 3 of those. The triangle, I need 2 of those. I do have to manufacture these parts. So we have the opportunity here to adjust the item separation. And just a real quick look on the screen, they're pretty tight, pretty close. And really just for display purposes for everybody, I'm going to go ahead and bump that up to a 1/2 inch separation between them. We can ask the software our desired yield and the runtime or the performance of it. And then this is an important button. I don't know why you'd want to turn this off, but you can. You can hit OK, and it will go and process the new nesting study and develop the results based on the change that I made in the quantity and also the separation. So that's a quick nesting study there done. Basically, we didn't have any Inventor parts. In this case, we simply used DXF to bring in some 2D AutoCAD data. I'm going to show you today the ability to machine these nests using the HSM solution. But we do also understand that a lot of our clients are doing their machining still perhaps within the AutoCAD environment, or within a piece of software that requires a DXF file, for example. So on the sheet itself, I can right-click on that and export that and send it back out as a DXF file so that you can bring it back in now as a nest and use the software of your choice to go ahead and machine those parts. In working within Inventor, again, keeping in mind that this was a flat 2D AutoCAD file, if I wanted to machine this within Inventor, I can right-click on this and have it create a 3D model. And it will do that nicely, actually, by not only the 3D model, but also the sheet itself. And the thickness came from the material. Okay, so very quickly we can take that right into HSM and begin machining it. And you'll notice now that I'm actually in a different file when it created that 3D model, but the nest is still over here. If you wanted to go ahead and edit more components of that nest, you can do that, have it recalculate. I have the automatic update button on, and if you wanted to, you could also go and look at different materials. Here's the material library. You can add your own materials. You can add materials from providers. You can see that the software ships with several different kinds of materials. You can control the thickness here of the material, the nesting color, or any other properties that you might want to associate that with it. And there's also some options for the grain flow of the part from within the material, and again, the separation and so forth. That is the default. That's where that 40,000 came from, that I was able to change to a 1/2 inch from you. And you can add your own materials here, change the thickness and so forth, change the material if you need to. So far, pretty simple, pretty straightforward. To go then to the individual piece part, again, just to reiterate, we are working in what looks like a piece of wood here, and that was my intent because it does work well in the woodworking industry. But I will tell you that when I created this part, I used the sheet metal template and not the standard template because of the nesting utility requirement of working with sheet metal components. So I created the sheet metal part using the sheet metal template, generated quickly a face with some cuts, and we have a sheet metal part. And then I just hit the unfold button, which really didn't do anything graphically, but it did then generate the flat pattern from inside the IPT, which again, to re-emphasize that, is a requirement. So we'll go back home. I will do a new nesting study, except this time we're going to pick a different source file. Pick the button to add, there we go. Click add, and I'll go grab that individual IPT file. I named it woodwork, and really what I'm trying to do here is emphasize for our woodworking friends that this solution can be used to help you with those wood parts. So I'll go ahead and add the woodworking part. I could add, again, 1, 2, 22, 200, but I'll go ahead and add that. That's the source file. This is a great little message that came up. It says that the material thickness that I have for this in the sheet metal part, based on the sheet metal properties, is wood. I used birch, and it's 1/8 of an inch thick. Perhaps that's a little thin for woodworking, or at least looking around on my desk, but that's what we have. So the nice thing here is that the software has recognized that this material is not in the library, and it's asking me politely, hey, do you want me to go ahead and add that for you? And I'll say, yes, thank you very much. So it has added that material for us. It's a quick process. So once we've done that, we'll go ahead and repeat pretty much the steps that we took before. Again, we are in the nesting environment. Our browser has changed to nesting. So I can go to create the nest. It's a new study. I can call it woodworking, or how many parts I want. There is the thickness of it. These max and X and max Y actually come from the piece part. The software is building, it's kind of like a rubber band, I might say, around it, of what the maximum shape is in the X and Y axis. It has found the material, not found, but it built the material for us using that thickness. This material here is 500 inches in length and width. That's something that you can adjust from within the material library based on perhaps your ERP system, or simple enough you walking out with a tape measure to measure it. Right now we just have the single shape selected. It will go ahead and build that nest. And again, it's basically just the individual piece part from within the nest on a sheet that's 500 by 500. I'll go ahead and edit that and tell the software that we actually need 5 of those. Go ahead and rotate or do whatever you need to get them in there nicely. And again, the item separation, I'm going to bump that up again for manufacturing purposes, and for display purposes, we'll okay that, and very quickly it calculates, and we have our new nest. And just for kicks, if we wanted to, we could go nuts here and say, I'm sorry, 55, typo, okay. Let it do its thing. Processes here in the browser, so you get an idea. And there you go. Quick, easy, and very effective. All right, so let's now step over to, I've got a nesting here for the DXF. I've got a nest here for an individual piece part. One thing that I do want to show you, under the nest, the hierarchy, there is a report, and we can go ahead and look at the properties of that report. And this may make more sense to people who are familiar with nesting and utilizing material. But you can see the different parts listed and the overall remnant area left, the nesting efficiency, the cost, which comes out of the configuration, the machine time, the nesting time, and so forth. But when we go to HSM here shortly, we'll also be able to get cycle times based on the machine and the post-processor that we're using. So we have the nest, we have the report, we have the sheet, and we have all of the items underneath that sheet. You can go right to an individual item, which would be helpful if there were multiple different items on here. You can rename items and so forth. And one of the things that we stress often is if you're looking for something the first place to check is underneath your right mouse button, and you'll see calculate. The properties of that pulls me right back to the edit nest. So I can use the ribbon button, or I can use my right mouse button, whichever you're comfortable with or is easiest for you. Getting a little more complicated now, we'll go to sheet metal assembly. Sorry, an assembly that contains sheet metal components. It's a large assembly, but to point out that some of these parts, you can see that even though there are no bends in it, the IPT file itself, again, emphasizing maybe too much the requirement of having a unfold within the part, and that the part has to be a sheet metal part. And I'm in the assembly here, the IAM file, and I can see all of those sheet metal parts, and looking at the browser, I can see that there are components in here that are not sheet metal parts, and the beauty here is that no problem, those will be ignored when we do the study. So again, just to repetition and show you those steps again, I'll go back home. I will create a new nesting study, and in this instance here, I'll add as my source file the assembly file. So I don't have to use Shift and go and select 22 different IPT files, although that would work. It would work. I'm going to pick on the assembly file, which contains sheet metal components, and maybe I don't even know what they are. I'm just going to nest this part. And we'll go ahead and add that assembly as our source file. And again, just to reiterate, it went through, the software did, analyzed the source files, and determined that everything is mild steel, which is great. But in my installed out of the box, these materials for 1/8 inch, a 1/4 inch, a 1/2 inch, 3/8, and so forth, we're not in the library, so the software is going to go ahead now and add those to the library and then begin the process of the study. And this will take a little bit of time. I apologize for the dead air, but there's a lot going on here, and you can see on the left as it goes through each and processes each component, so that it does give you some feedback on where it is and how it's doing. Good opportunity perhaps for me to clear my throat. So this goes back to the old saying that I've used over and over, is if you have the tools and the capabilities, let the software do the work for you. And that's exactly what's going on here. So as we tap our feet and strum our fingers waiting and perhaps getting impatient, it's important to note that a lot is happening while this spins. Taking a little longer than usual, but here we go. It woke up, I hope. The famous moving green bar. So that's done. Seemed like forever, didn't it? But it wasn't really in the realm of things, considering that these are all of the components that the nesting study went through and processed and brought these files into our study for us. So it looked at each file, determined its overall boundary, and we're ready to nest this. Am I the only one that always rolls the wheel the wrong way? I always do that. Okay, so the sources are loaded. Again, if we look at the processes, one thing to point out is that it also found in that assembly not only each sheet metal component, but it also found the quantities, which is awesome, right? So it found that there's actually 1301-0381.ipt in that assembly. There are 6 occurrences of that. So it's doing quite a bit of work while it's doing that process, getting the source files and the quantities of those source files. So we'll go ahead and create the nest. You'll see that here are all of the components, what their boundary definitions are, their thickness, their material. If there was a different material in this assembly, aluminum or what have you, it would have made a package or a sheet for that with that material size. So we have different packages here, 5 different packages. Get a good view at it, and we'll let the software do its thing and create those studies. Here's the process that's going on. And this might be an opportunity to mention that the Autodesk purchased a product called TrueNest. Some of you may have heard of it. It's out there on their Autodesk website. It's a very elaborate nesting utility that runs on its own. It's a separate application, costs money, and I believe lots of it. The nesting utility is basically a takeoff from that technology. So they stripped out from TrueNest just the nesting side of it and brought that into Inventor for us. And of course, if I practice this, it would be faster than me doing it live in front of you. So once this study is done, we'll see 5 different nests, and what we'll do next is go ahead and take this over to HSM or one of the sheets based on time, and put some toolpath on it and post-process it out with G-code to go right straight to your manufacturing machine. I am running on a Microsoft Surface. It's a great machine, very quick. I love it versus hauling around a large laptop and brick, and it handles these products very well. It's loaded up. It's got enough RAM in it and enough hard disk space. Let's go over to this nesting study here. Basically what I'm doing is taking advantage of the core and letting this process. I guess it got done when I did that, so I can show you those. Oh, it's still working on one of them. But to keep things moving, nest 5 appears to be hung up. We'll go over now to a simple nest that we created. And there's the sheet, and right now it's a flat pattern, so I'm going to go ahead and create a 3D model out of that. And it looks at, again, the material thickness and so forth. This a little bit out of the way. And so there is the material. And here are the individual piece parts from within that material. It's got the thickness on it that we've defined also. Let me go back and take a peek at this. And maybe we'll So much for that guy. All right, sorry to be switching screens on you so much. I'm back at the assembly. I canceled one of the sheets that was giving me a little bit of trouble, but here you can see the components. As it extracted those components, it is nesting multiple piece parts on an individual sheet based on their thickness. Here's sheet 4. Sheet 2. Roll the wheel the wrong way. Sheet 4 and sheet 3. So that gives you an idea, and my objective today was to kind of take you through all of the options as far as AutoCAD to the nesting utility, individual piece parts to the nesting utility, and then assemblies to the nesting utility. We'll change gears a little bit, and we're running now into the HSM environment. HSM is the tool that you use to apply toolpath to your parts, and you have full control over this. The HSM environment is a ribbon that is added to your Inventor, hence it's an add-in. And to just reemphasize, it is a separate download and a separate install, but it is free if you are on subscription. So we'll go into the CAM environment, HSM, and what we're going to do is, first of all, tell the software what is our piece parts and where is 0, 0. So I'll run through the setup, and in this case, the software has defined stock for me. It's put some nice little blips around the outside of the part. Basically, this is a useful tool for me or for you so that I can define where is 0, 0. In the setup, I'm going to tell the software that I'm not milling, I'm not turning this, I'm going to be cutting this. And the origin is going to be a stock box point, which will be the bottom here. And you can pick any one of these blips and change your origin, change the orientation to whatever you might want it to be. If you click on the axis itself, it'll flip that. In this case, we would have Z0 in this corner and positive Z coming towards us, positive X going down the bottom, and Y going up. And from there, we're pretty much ready to go. As far as the setup, the browser, it added a CAM browser for us. Again, for our history, the setup has been created and is the default. Note here, you can have as many setups in here as you want. So we could have a setup for torching this out, and then we could have another setup if it goes to a milling machine and pop some holes in here, and that can all reside from within this one file. So from a file management standpoint, your NC program is contained within the Inventor file. So it's not a separate file that we need to worry about. We'll go, again, there's the software is capable of all kinds of milling, 3D milling, all the way up to full 5-axis, which would be this ribbon turning, simple turning, multi-spindles, or multi-chucks, threading, and so forth. So there's a lot of capability here. It's something that we could spend an hour on really all by itself. But we're going to go ahead and do the 2D profile operation on this nest You have options here. Is it a water jet? Is it a laser? Is it a plasma? Are we going through it automatically? What is your quality interest, or are you etching? And here is your kerf width, in this case, of that plasma. We'll then go and select the contours. You can see how it changed them all together nicely. If you make a mistake and you don't pick one, you can go ahead and hit the red X and tell it to select all of the same faces. You know, I have 5 parts here, but if you have 55, you don't want to sit there and go click, 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 click. So close all the loops and so forth. And this red X is something that a lot of people miss when they're learning. It's just basically a deselect. Okay. And if you did have you know, different faces for some reason, you probably wouldn't see that from within a nesting study. You can pick them differently because on the levels tab, that height or where we're going through, the material that we're going through is determined here by the top of the stock, but it could be the bottom or whatever option you want to choose here. There's then the passes tab, and real quick, this is where you can control compensation, or if you want to leave stock. I tell people that the passes tab is in material or applied while in material, and then the linking tab is what you would use to get around the material, perhaps moving from one shape to another shape. We can keep the nozzle down and so forth. But once you again move from left to right, and I spent more time explaining it than it would take you to do it, we basically picked the plasma shape. We told it to go down to the top of the stock. We hit OK, and it will then generate our profiles around that. Now, in this case, it's a little bit small, perhaps to see on the screen, but we can simulate that. And that's another reason why I opened up my distance between the nested components, where I was interested in having a lead in and lead out. Now, obviously, we could make that separation between the components tighter to better utilize our material. So very quickly, we were able to plasma cut these out. It generated our G code here for us, or our toolpath. And again, if you're looking for something, check your right mouse button. You can edit that at any time, and it will pull you right back up into the same environment that we were at before. We can also get machine time here, how long it takes to machine that part based on the the shapes and the feed that we're moving within. Tool change not so much applied here, but you get a lot of feedback on that. You can show a log if you do get errors. I use this quite a bit. From a technical support standpoint, you can look at log if the software's triggering an error for you at all. But basically, going from an AutoCAD DXF file into the nesting utility to generate the nest, into HSM to apply the toolpath around it, and then we'll go ahead and prepare it for the machine tool, meaning that we need to create code that the machine accepts. I'm going to use the Hypertherm jet here, but if I pull that down, you'll see that the HSM software includes basically several dozen different post-processors right out of the box, installed automatically for milling, turning, plasma, laser, and so forth. So we'll go ahead and post that. And here is our G-code. And this is what we would then send to the machine tool to actually have it machine those piece parts. And it's kind of a mini DNC system. I wouldn't go full blown here and oversell this. But if you are connected to the machine, we can send that right to a machine tool here also. So that was the purpose of today's event, was to run you through the workflow. And the important thing to point out here is that we are utilizing software that you already own, or it's very possible that you already own. So I've told a lot of people before, if you already have a CAM system, I understand. Once you get one, man, you keep it and you keep pumping out parts. But because this is something that you already own, I would encourage you to, stick your toe in the water and begin working with some of these different applications. So that really concludes what I was going to show you from a technical perspective. I do want to mention, before we call it a day, that we are also capable here of handling your document management systems with Vault or Meridian or Adept. We've done a lot of document management where we see that we're dealing with DXFs and IPTs and IAMs, and you probably have bill of materials and so forth. A document management solution can be very valuable. And it's also worth pointing out that the nesting utility is yours. If you're on subscription, you already own it. HSM is yours. If you're on subscription, you already own it. And don't forget that Vault is yours if you are on subscription. We also provide simulation services if you need to, or if you have a worry about some of these sheet metal bends and analysis. We have over 30 years of that, and we can help you out. Outside of the engineering department, we can help you out with your document management and your simulation services. So I want to thank you. I'm going to, I don't know if we have answered all of your questions or not, but if there's anything, I don't know, Clayton, if you're there or not, if there's anything there that did or did not get answered, I'm willing to stay here and try to answer those. Here's one from Kevin. If we have a machine that's not already covered on your list of machines, how hard is it to add one? Depends on the machine. But anyway, we do have experience with post-processors, and what we mentioned to a lot of people is with all of those that are listed, we first find one that's close, and then we can tweak those specifically for your machine, and that is a service that we do offer. Can an assembly be added that is made of multiple? Oh yes, absolutely. Yep. Does the nesting utility work with assemblies within assemblies? Yes. The source file, if it's an assembly and it has sub-assemblies, yes. Yes, it does. If you put a part on a sheet and you find that it isn't filled, can you re-add more parts? Absolutely. If you've already generated the 3D model to take it to manufacturing, that will have to be redone. But yes, we can go back to the source and add components. Kevin, I'm not familiar with that machine, but again, if we post out G code, and if you have an example of that Hank Wing laser, we can find some G code that gets us close and tweak that to make it more specific. Can you orient the parts anywhere on the sheet from Ed? I'm going to say no to that. The nesting software is doing a lot of the calculations in the background, and it will do that nesting for you. So you can't just plop one here and put one there, at least not using the nesting utility. Paul, I'm not too sure what you mean by a parametric example. The nesting utility is a part of the source, so if that source file changes, you can then go back to the nesting utility and regenerate your nest, and it will update. I have trouble not getting the dimensions to show up in the DX when I export a nest. That would probably be something that we would have to look in. I'm not sure which dimensions, if you're talking about the DXF files themselves or the dimensions on the screen here. That might be something that we need to run through support to figure out. How would you run a job if you needed a batch of 5 plows? Okay, the source determined the numbers of those. There's a couple different ways you could do that. You could build a quick dummy subassembly that has your 5 in it and use that as the source. Or we could run the nesting utility 5 times. Ed, can you orient the parts anywhere on the sheet? No. Again, the nesting utility is going to do that. And what we may have here with some of these questions is automated versus manual. The nesting utility is calculating things on its own and taking advantage of material and basically the gap that you define and doing its own thing. You can rotate. It doesn't have to be in increments of 90 degrees. It can orientate in other degrees, but you do have control over that. Where you can control the degree deviation. So it could be 10-degree increments, 15-degree increments, or whatever you might need. Yes, the dimensions on the screen that are being missed, we'll have to look into that, Sarah, probably offline. Yes, remnants, those can be saved off as a material and used. And another thing, if you get into a lot of different remnants, you go ahead and pull up the Autodesk site and look at the TrueNest solution. That has a lot more control over more ERP, remnant control, and so forth, where the free Inventor Nesting Utility is that. It's free and it nests based on a sheet. Can you etch part? Absolutely, Ron. You can etch part numbers with the HSM using different types of fonts also. Might be a different question I asked earlier. The job quantity, couldn't control that. We might take that offline, Rob, just to make sure that we know what you're talking about here. Having trouble getting the spacing correctly, that's back here at the Create Nesting Utility. Got this screen up here. No, it's not. Cancel. Let's go to this nested sheet. I can edit that sheet. And here is your item spacing. I hope that points you in the right direction. For Sarah. Jordan Learning on the water jet, we'll take that offline. I'm not quite sure on that, but I will tell you that on the CAM side of things, in this profile operation, here are your quality control using the machine's quality or the machine speeds and speeds. You have full control over that. I've run over yeah, Sarah, we'd have to look into that. I'm not sure why the spacing would tell you something differently, although if we look here, package 5 has that spacing. It should adhere to that. If it's not, there must be a reason, and we'll have to investigate that. All of the questions are going to be provided back to us. I hope that we got most of them settled for you. If not, you can always contact us also once you go through it. But do look at the TrueNest software that is Autodesk's if you are getting into remnant control and so forth. The nesting utility, again, is a free add-in to the software and really honestly focuses on nesting itself. So we may run into some questions where it's just frankly a software limitation. So I apologize for running over. Ashley, I'm going to throw this back over to you and let you close it out. And I do thank everybody for attending.
Okay, thanks, Tad. Yes, this will conclude our broadcast. If you think of additional questions, you can simply reply to the confirmation or reminder email you received from GoToWebinar. We can get those to Tad or your sales rep to get those questions answered. Once again, if you could take a few moments to fill out the survey, we would appreciate it. It will just pop up as we close down today. Thanks for attending and have a great day, everybody.